Imagine asking your computer just to print out a single piece of paper, right?
Sounds easy enough.
Yeah, you'd think so. But by 2 a.m., you are somehow architecting this industrial data pipeline that, it just chews through 70,000 pages of code in mere seconds.
Which is quite the escalation.
Oh, totally. Have you ever let a quick, 5-minute tech task just spiral completely out of control?
Oh, constantly. You go in to fix a typo and suddenly you're reinstalling your operating system.
Exactly. Well, today, welcome to the deep dive. We are actually following this fascinating chronological chat log between a user and an AI named Claude. We're going to watch this incredibly innocent request just, mutate into a massive, complex software engineering project.
It really is kind of the ultimate study in scope creep. But more importantly, I think, it's this amazing window into how problem solving actually happens when humans and artificial intelligence collaborate in real time.
Right, because we aren't just looking at the code they spit out.
No, not at all. We are really examining the invisible friction points of software design, the brutal reality of system bottlenecks, and, the strategies required to actually push through them when things break down.
So let's start at the very beginning, where things are, frankly, deceptively simple.
They always are.
Yeah. The user is working in Visual Studio Code. They have a Python script, and they just want to print it out to read on actual paper.
Yeah.
Or, at the very least, save it as a PDF file.
Right, but there's a catch.
There's a catch. They want it to look exactly like it does on their screen. So with the nice syntax highlighting the line numbers, the proper color-coded indentation, all of that.
Which, ironically, highlights this really surprising gap in modern development environments. Because VS Code doesn't actually have a native high-fidelity print-to-PDF button that preserves all that visual metadata.
Wait, really? The most popular code editor doesn't just let you hit print and keep the colors?
Strangely, no. So the user actually has to ask the AI for help with this. And the AI just kind of lays out a menu of options. It suggests everything from basic text exporters to this highly polished Python library called Pygments.
Right. And the user goes with Pygments, probably because the AI specifically notes, that it offers the highest visual quality.
Makes sense.
And initially, it is a total breeze. The AI just gives them a terminal command, they run it, and boom, this beautiful color-coded PDF just drops right into their folder. Task accomplished.
The squeaky hinge is fixed.
Exactly.
Yeah.
But instead of just walking away, the user looks at their shiny new command line trick and says, can you create a graphical user interface for this?
And right there, that is the exact moment the entire trajectory of the project shifts.
It's the point of no return.
Oh, completely. So the AI recommends a framework called Tkinter, which is, it's Python's standard toolkit for building desktop applications.
Okay, so we're building an app now.
Right. Think about what is happening here. The user is abandoning a single line of text in a terminal to build a standalone desktop app. We're talking file browsers, visual themes that match VS Code, style drop-down menus.
That's a huge leap.
It gets crazier. The AI even has to introduce multithreading.
Wait, hold on. Multithreading. I thought we were just putting a nice little window around a print command. Why do we suddenly need multiple threads of processing for that?
Because graphical interfaces need to remain responsive, right?
Yeah.
So if you click a button to convert a large file, the computer's processor focuses entirely on that conversion task.
Oh, so the window would just freeze up.
Exactly. If you don't separate that task into a background thread, the entire application window will just freeze. You'll get that dreaded spinning wheel, and Windows will say, not responding until the conversion finishes.
Oh, I hate that.
Right, everyone does. So the AI actually has to actively engineer around these limitations of user experience.
Wow. Okay, so they build this multi-threaded application, and the user immediately asks to add batch processing for entire directories.
Naturally.
I have to push back on the logic here, though. Building a full desktop application, worrying about UI themes and background threads just to print some code. Is this actually efficient, or are we just watching a user get completely intoxicated by the fact that an AI will just write whatever they ask for?
Oh, it is entirely the latter. But that represents a fundamental psychological shift in how we approach software today.
How so?
Well, historically, building a graphical interface was a massive investment. You had to plan it, handle error states, manage all the event loops. You just wouldn't do it for a one-off print job.
Right. You just type the command and move on.
Exactly. But today, the AI lowers that barrier of creation to almost zero. When the cost of asking for a custom tool becomes cheaper than the mild annoyance of typing a command twice, the tool itself becomes the project.
Oh, that's such a good point. You stop trying to solve the immediate problem and start trying to, like, automate the entire category of problems.
Yep. It feels like a superpower.
Yeah.
You ask and the AI builds.
But this honeymoon phase of instant magical coding hits a massive brick wall pretty quickly.
Oh, a huge one.
Yeah, the user decides their new app is so great they want to add a third tab to it. This time, they want to convert HTML files into PDFs. So the AI suggests a new library for this, but suddenly things stop being so easy.
Yeah, welcome to dependency hell.
Seriously.
The AI recommends a library called WeasyPrint. Now, WeasyPrint is an elegant piece of software written in pure Python, which, sounds absolutely perfect.
Sounds like it should just plug right in.
You'd think.
Yeah.
But to actually render HTML into a PDF document, WeasyPrint relies on external system-level libraries, things with names like GTK and Pango.
Right. And the major plot twist here is that our user is on a Windows machine. Why does that turn these external libraries into such a nightmare? I mean, isn't Windows the most popular operating system in the world? Why wouldn't these tools just work natively?
It really comes down to fundamentally different philosophies of system architecture.
Okay, unpack that a bit.
Sure. So GTK and Pango are deeply rooted in the Linux open source ecosystem. And Linux is built on the idea of a communal environment. Small, specialized programs are constantly talking to each other and sharing resources freely across the whole system.
Like a big open community.
Exactly. Windows, on the other hand, well, it prefers a walled garden. It wants applications neatly packaged in isolated boxes with all their own parts included.
Ah, I see where this is going.
Right. So when you force a Linux native tool onto Windows, it looks around for this community of shared libraries that simply does not exist.
So the AI has to somehow, like, build that community from scratch on the user's computer.
Yes. And the instructions it starts giving are just staggering. It tells the user they need to install an entirely separate environment called MSYS2.
I remember reading that part of the log and just thinking, what even is MSYS2?
It's essentially a translation layer. It creates a miniature simulated Linux environment running inside Windows, literally just so these specific libraries can function.
That is wild. The AI is giving the user these incredibly complex terminal commands, having them download specific packages, and then telling them to manually dig into the Windows control panel to edit their system's environment variables.
Just to point to new directories, yeah.
It is absurd. I mean, it's like discovering you need a translator for a meeting, but the translator requires a special visa, and the visa requires background checks from 3 different countries.
And you have to personally drive the paperwork to each embassy.
Yes. Exactly. It's so much friction.
And this exposes a really critical limitation in how AI collaborates. Because the AI possesses the technical knowledge to configure MSYS2 and edit those environment variables flawlessly.
It knows all the steps.
Right. It will happily and logically walk you down this incredibly complex path because, strictly speaking, this is the technically correct way to force WeasyPrint to run on Windows.
But the AI doesn't feel friction.
Exactly. It doesn't get tired. It doesn't experience the cognitive load of switching between control panels and simulated Linux terminals.
But the human user absolutely feels that friction. They go through all of this, the app still fails, and they finally just hit their breaking point. The user types into the chat, literally, this is utterly insane.
Which is a perfectly rational response to the situation.
I laughed out loud when I read that. And the AI's response is amazing. It actually apologizes.
It really
It
does.
says something like, you are 100% right. I completely steer you wrong on this one. WeasyPrint on Windows is a nightmare, and I should have warned you up front instead of sending you down this rabbit hole.
And this is exactly why the human in the loop is so critical. The human acts as the reality check here.
Right, because the AI would just keep going forever.
Yep. The AI has infinite computational stamina, but the human understands the return on investment. The human is the one who steps back and realizes that, spending 3 hours configuring simulated Linux environments just to make a simple PDF is a terrible trade-off.
Totally. So they completely scrap WeasyPrint. They try another tool that, tries to silently run Google Chrome in the background, but that just spits out a timeout error.
Classic.
Yeah. And finally, the AI pivots entirely, stops trying to be elegant, and suggests a tool called wkhtmltopdf.
Which is a profound shift in strategy. wkhtmltopdf is a standalone binary executable.
What does that mean practically for the user?
It means it is a fully compiled, completely self-contained program. It doesn't need a simulated Linux environment. It
Yeah.
doesn't need shared libraries. It doesn't need to hijack a web browser.
Oh, thank goodness.
Right. It is a single, heavy block of code that takes HTML, processes it internally, and spits out a PDF. Boom, done.
The AI actually calls it rock solid and no nonsense.
Mm-hmm.
So the user plugs it in, the app shows a green banner confirming the tool is detected, and it works flawlessly. The dependency chain is broken. They've finally escaped the rabbit hole.
It perfectly illustrates that sometimes the quote-unquote best or most modern software library is actually the completely wrong choice if the environment aggressively resists it.
That is such a good lesson. And having survived that ordeal, you would really think the user would take their working app and just call it a day.
But of course they don't.
Of course not. They decide to introduce a new challenge that pushes this little Tkinter tool to the absolute limit. They want to parse a Google Takeout file containing their entire YouTube watch history.
And we are not talking about a normal web page here. We are talking about an introduction to the brutal realities of data scaling.
Yeah, the file is 70,000 pages long, 70,000 pages of dense, repetitive HTML code.
It's massive.
The user's goal is to filter this massive history by a specific keyword, like Arduino, extract those specific video links, and turn them into a clean PDF.
Okay.
To do this, the AI reaches for a very famous Python parsing library called Beautiful Soup. But almost immediately, the user reports back that the parsing is taking an excruciatingly long time. The app is practically choking to death.
This brings up a really fundamental law of software engineering, which is scaling up breaks everything.
I love that.
Yeah.
So true.
Beautiful Soup is an incredible tool for understanding the structure of a web page. But it fails spectacularly here because of how it processes data. It uses something called a DOM tree, a document object model.
Okay, so what is the actual mechanism happening inside the computer when it builds a DOM tree? Like, why does it cause the app to choke so badly?
Think of it like a car mechanic looking for a specific spark plug.
Okay.
Using Beautiful Soup is like taking apart the entire car, laying every single nut, bolt, wire, and panel out on the garage floor, and drawing a massive complex map of exactly how every piece connects to every other piece.
Wow.
You map the whole car just to walk over and pick up the spark plug.
That sounds horribly inefficient.
It is. In computer terms, it reads the entire 70,000-page document into the system's active RAM at once. It maps every parent element, every child element, every nested table, and holds all those relationships active in memory simultaneously.
So it's not just the sheer size of the file, it's the weight of the structure it's building. The computer just runs out of garage space instantly.
Precisely. It's spending 99% of its processing power maintaining the map of 70,000 pages, leaving almost nothing left to actually search for the word Arduino.
So they need a radical shift in strategy. They have to, abandon the idea of understanding the document structure entirely?
Exactly. And this is really the technological climax of the whole journey. The AI completely drops Beautiful Soup and builds what it calls a regex-based streaming parser.
Let's unpack the mechanism here, starting with the regex part. Regex stands for regular expressions, right? How does that fix the car mechanic problem?
Well, if Beautiful Soup is the mechanic mapping the entire car, regex is like a highly trained search and rescue dog.
Oh, I like that analogy.
It completely ignores the layout of the forest. It doesn't care about the trees, the paths, or the elevation. It just sprints straight toward the specific scent you gave it.
So the AI asks the user for a tiny snippet of the 70,000-page file, just a few lines around one video entry. And it discovers the file is basically one giant continuous string of text.
Right.
So the AI crafts this highly specific regex pattern. It essentially tells the computer, hey, ignore all the HTML rules, ignore the tables and the divisions, and just look for the literal sequence of characters that spell out the word watched, followed by a link, a title, and a date.
It totally abandons structural understanding for raw pattern matching. But that alone doesn't actually solve the memory problem.
Well, why not?
Because you still can't load 70,000 pages of text into RAM at once without risking a crash, reject or not. That is where the streaming part of the parser comes in.
Ah, okay, so instead of swallowing the whole file at once, the AI tells the program to read the data in tiny bytes. Specifically, I think it was 512 kilobyte chunks.
Yep, 512 KB.
So it takes a byte, lets the regex dog scan it for the pattern, saves the matches, and then just throws the rest of the chunk away to free up memory. But why couldn't the old method, Beautiful Soup, just read the file in chunks like that?
That's a great question. It's because HTML is a language of rules and pairs. Every time you open a structural tag, like a div tag, you eventually have to close it.
Right, with a closing div.
Yes. So if you slice an HTML file blindly at 512 kilobytes, you might slice right through the middle of a structure.
Oh, I see.
The parser will see an opening tag, but never see the closing tag because it's in the next chunk. The parser will panic and throw a fatal error. It physically cannot understand half a structure.
But the regex dog doesn't care about opening and closing tags. It just looks for letters.
Exactly.
However, chunking still introduces a massive risk, doesn't it? Like,
Yeah.
what happens if the word Arduino sits exactly on the boundary line between one chunk and the next?
And that is the classic pitfall of streaming data. If the program reads Arduino at the very end of chunk 1 and Inno at the very beginning of chunk 2, the pattern matching
The
fails.
word is broken in half.
Right, the entry is completely lost, and the user would never even know it was missing from the final PDF.
And the way they solve this is just brilliant. The AI engineers a 4 kilobyte overlap at the chunk boundaries.
It's so smart.
It is. It reads chunk 1. Then, before it reads chunk 2, it actively steps backwards 4 kilobytes into the data it just read.
It's this really elegant mechanical failsafe. By overlapping the reads, it guarantees that no entry, no matter how awkwardly positioned in the text, can ever fall into the gap between chunks.
The architecture of it is just incredibly satisfying. They even program in deduplication, so, if the user watched the same video twice, it only records it once.
Literally.
And the result? The processing time plummets from minutes of frozen screens, and system crashes down to mere seconds. Watching a specialized tool chew through that much information with such surgical precision is honestly amazing.
It is. Yet for all this computational gymnastics, the most revealing part of the entire project is the final output. Because the end goal here was never for the human user to just sit down with a cup of coffee and read a PDF of their YouTube history.
Right. The user reveals they want to take this highly specific, filtered data and feed it into a completely different artificial intelligence Google's Notebook LM.
And that fundamentally dictates how the output is designed.
How so?
Well, when the AI generates the final PDF, it doesn't look like a normal document. It structures the data into highly clinical metadata cards.
Right. Every single entry gets a distinct card with a thick blue border on the left side. It lists the topic, the exact title, the clean URL, and the date. It looks like a database printout. Why the blue borders and the rigid layout?
Because analytical AIs like Notebook LM struggle immensely with raw, messy web formatting.
Interesting.
Yeah, if you feed them chaotic HTML, they get confused about hierarchy and context. By structuring the data into highly separated, distinctly bordered metadata cards, the user is ensuring the receiving AI can perfectly index every single data point.
So it won't hallucinate or mix up the video titles. The human user in Claude didn't just build a parsing tool. They built a bespoke, high-speed data translation pipeline. They took the chaotic, heavy formatting of Google Takeout and stripped it down into a perfectly standardized format explicitly designed for machine consumption.
It is a profound shift in the role of the human operator. I mean, the user is no longer the consumer of the data. They are the orchestrator, building a highly optimized bridge so two distinct artificial intelligences can communicate effectively.
Looking back at this entire journey, it's wild to think it started with a simple desire to print color-coded text.
Truly.
They cascaded into building a multi-threaded Tkinter desktop app. They tumbled down a horrific dependency trap with MSYS2 and Linux libraries before fighting their way out using a standalone binary executable.
And finally, they smashed through the 70,000-page scaling wall by abandoning structural parsing and engineering a regex streaming parser with overlapping boundaries.
For anyone listening to this deep dive who is navigating their own technical roadblocks, whether you're coding or, just trying to get your office software to cooperate, the takeaway here is immense.
Definitely.
The next time you hit a wall, remember this chat log. Remember that if your environment is aggressively resisting you, if you're installing translation layers and special visas just to make a single tool work, you are probably fighting the architecture.
Stop forcing a heavy tool to do something it doesn't want to do. Step back, recognize the friction, and change the approach entirely. Find the standalone tool. Find the regex stream that simplifies everything.
It's about matching your strategy to the reality of this system. And, well, it leaves me with this final, somewhat provocative thought to leave you to mull over.
Let's hear it.
We just watch a human spend hours collaborating with an AI to architect a program that perfectly formats data to be fed to a completely different AI.
Right.
As these tools become more prevalent, are we rapidly approaching a future where humans are simply the project managers, just initiating the spark, while AIs spend all their time negotiating data formats, building translation pipelines, and talking amongst themselves? Maybe. Eventually, we won't even need to be in the room when the software is being written.